Hello, good evening. How is your day going, or how did your day go? Those of you that are back from work, I want to welcome you back, and I hope you had a stressless day. Please, I'm doing this video in respect of the challenges I'm having when it comes to my course page. I am having a serious technical issue, which is making me not to be able to connect with the link. I've been trying all the while to connect so that I'll be able to have a live facilitation, but I couldn't connect. I don't know what the issue is. I've tried to contact the technical people. They are not giving me any solution yet. So I want to seriously apologize, especially for those of you that came up online. I apologize. It's not my making. It's just that I cannot help it out. And that is why I am putting up this video as an alternative. So I want to welcome you seriously. I want to welcome you seriously. God bless you. And last week we started with this topic, CIT108, problem solving algorithm. We are able to introduce what problem solving is, and we are able to talk about some of the algorithms that are used in solving problems in computer science and information technology. Like I told you last week, when you talk about problems, one of you define problem as challenges that one have. It is also defined in that term when it comes to computer science or information technology. And I remember also mentioned that when you are solving a problem when we talk about problem solving, we are talking about real world problem that comes up in computer science. And some of you will start, we get to know some of these things, especially when you start writing your project, your mini project, your seminar. You will start, you get to know what this topic is all about. So we are able to define what problem solving is, what a problem is, what problem solving is, and the approaches we use in solving problems. One of the approaches we use is the trial and error method, like we said last week. Another approach we use is the means end approach. Another approach we use is the algorithm approach, and the final approach is the heuristic approach. So all these are in your book, and I was able to say something about them. So those are the approaches we use when you talk about solving real world problem in computer science. Today we are going to enter into a different lesson, and the topic of our lessons today is the problem solving processes. The problem solving processes. What are the processes we use in solving problem in computer science? What are the processes we use in solving problem in information technology? So the processes are what we are going to study about today. At the end of the lesson, you should be able to define computer as a model of computation. At the end of the lesson, you should be able to explain the problem solving process in detail. At the end of the lesson, you should be able to apply the problem solving paradigm to routine elementary problem. Computer as a model for computation. You know, as a computer or IT student, there is no way you can talk without talking about computer as our model for computation. There is no way. An average IT person is expected to know how to handle computer, even though it is at the basic. So we are talking about computer now as a model, that is the computer machine, the computer system. Problem solving is a sequential process of analyzing information. Like I said last time, somebody said it's a way of solving your challenges. It is a way of analyzing information related to a given situation or a problem, and then you generate appropriate option or responses. Whenever you have a problem, you first of all analyze the problem in relation to what your problem the situation on ground, and then generate appropriate response from that problem or output. Solving problem using the computer system can be done using the input, that is the keyboard, the mouse, information or game control movement, using the processing or inputs. You can also get your outputs when you solve a problem. And one of the outputs you get is your images, your text, or your sound. Sometimes the incoming and outgoing data may be the form of hard drives or network devices. So computer is our model whenever we are talking about solving problem in computer science or information technology. In solving a problem, there are some well-defined steps to be followed. That is where I'm going to. For example, consider how the input process and output process work on a simple problem. Let us take an example now. If you are given a problem like this, calculate the average grade for all staff or all students in a class. Calculate the average grade for all students in a class. We can obtain the result by following three simple steps. And these three steps are what the processes or the steps that are involved for you to get your output. Number one, you have to gather data. That is the input process. Gather data and input it. That is the number one process. Get your data. They are talking about average grades. What are the grades? What are the data? What are the scores? You have to gather these scores first. After gathering these scores, you will process it. Let me take an example now. You are using Microsoft Word. Microsoft Excel. When you talk about calculation, Microsoft Excel is better. So if you are asked to calculate the average grade for all students in a particular class, first of all, get the data. Input the data into the system. That is probably Excel. So when you have input this data, you know the scores of these students. You can now give a command. This is the second step, processing. When you give this command, an output will be generated. But mind you, the processing is done mainly by us, by the woman operating the computer. If you don't give the computer any command, it will just be there looking at you. Your data that you have entered will be there looking at you. So you have to give a command, and one of the commands you give, for example, like this question, they say the average score. After you have gotten, you give the sum of a score. After summing it up, you can now do the average. When you get the average, it is left for you. If you want to do percentage, you can do the percentage. Then you print out the output. So that is your input, process, and output step you have to take whenever you are solving a problem in computer. But this one is on a lighter note. Is just for beginners. There are some other things we use computers to do that are more, how will I put it? They are not on this primary level. So you have to know some of them. Now, when we talk of problem solving, we want to understand some of the processes that are involved in solving a problem in computer science. When you have a problem in computer science or in information technology, what do you do? What are the processes that you embark upon? Number one, you have to understand the problem. What is the problem all about? You cannot solve a problem when you don't know what the problem is all about. And that is why, like I told you last week, that if you want to write a project on any topic, you must first of all read about it, because you cannot write on what you don't know. So number one, understand the topic, the problem. And one of the things that will help you to understand this problem is for you to ask yourself a series of questions. Ask yourself questions. Number one question you should ask yourself is, what data or information is what available? What are the information that are available for me to be able to solve this problem? That one is a personal thing for you. Number two question you have to ask yourself, what does the data represent? What does it represent? You want to solve this problem, but what does the data represent? It can represent a text, it can represent a graphic, it can represent an audio. So it is you that know what you want. So you have to understand the problem you want to solve. Number three, in what format is the data? What format is it? What is the missing data provided? That is another question you have to ask yourself. Out of all this data you have gathered, is there any missing data that you need that is not there? You go for it. Another question you need to ask, does the person solving the problem have everything needed? You have to be capable for you to be able to solve this problem. Do you have what it takes to solve this problem? If you pick up a problem that you cannot solve, you will hang on the way. So that is another question you need to ask yourself for you to be able to understand the problem to be solved. What output information needs to be produced? Have a mental picture. You cannot say you want to solve a problem when you have not have a mental picture already. Okay, let's take an example of somebody that wants to, an architect. If I come to an architect now and say, I want to build a 3-bedroom flat. This is how I want it to be. This is how I want it to be. The architect will picture what you told him or her. And from that mental picture, he will be able to sketch out what you want for the house to come up. So that is how it is. When you want to solve any problem, have a mental picture of what you want to produce. In what form should the result be? What form do you want your result to be? Is it through text? Do you want it to be through graph? Do you want it to be through? It is left for you. You are the one that will answer all those questions. When you have answered all these questions, that means you understand what the problem is all about. Then you can step 2 or process 2. Process 2 will formulate a model. Formulate a model. Understand the processing part of the problem. Many problems break down into smaller problems that require some kind of simple mathematical computation in order to process the data. You have to understand, like I said earlier, if you don't give the computer a command, it will just hang there. So you have to understand the processing part. If you don't know what to do, the command to give, the calculation to give, the formula to form, it will be very, very hard for you. So when you have a mental picture of what you want, then you formulate a model. It is you that will ask, okay, when I join this with this, it will produce this thing I have in mind. So you have to think, and that was why I told you last week that this problem solving algorithm course is all about you making use of your mental capability. You have to do critical thinking, logical thinking. So that is what it's all about. And that is what problem solving is all about. You think. So number two, formulate a model. When you have gotten, okay, this is what I want, then ask yourself, what are the processes I will use? If it involves calculation, then start forming calculation. Break the problem into parts. This one needs this calculation. Do the calculation of this one. Bring it together. Do the calculation. Then at the end, you bring everything together to what gets the problem solved. Step number three, process. Develop an algorithm. Come up with a precise plan of what the computer is expected to do using pseudocode or flowcharts. These are the two types of algorithm that we have. You can either use the pseudocode. Pseudocode, they are just general language, but it's a step-by-step plan, general English language, step-by-step program, step-by-step program that meets the need or that solve your problem. When you talk of flowchart is just a pictorial or a graphical representation of how your problem will be solved. So if you have developed your pseudocode or your algorithm, then you can now move to the fourth step. The fourth step is write the program. Transform your algorithm into a set of instructions that can be understood by the computer. The pseudocodes cannot be understood by computer because it's English. The same thing with the flowcharts. They are all English. The computer cannot understand it. The computer don't understand English. So you have to write a program that is compatible with the computer, that the computer will understand. And that is where writing of codes comes in. So you have to use that pseudocode or flowchart you have developed to write a step-by-step instruction that the computer understands and will use it to solve your problem. You can pick the programming language that best suits your problem and use it to solve that problem. After that, you enter the fifth process. Test the program. Run the program to evaluate the compiled instruction. After you have run the program, running the program means just testing to see whether the program gives you the desired result. If there is any problem, you can do what we call debugging. Go to the program, line up the program one after the other, check whether there is an issue. If there's an issue, you correct it, you run it again. That is the test running we are talking about. Test run the program. After you have test run it, then you can now evaluate the solution. That is the last process. Once the program produces a result that seems correct, the original problem needs to be reconsidered to make sure that the answer is formatted into a proper solution to the problem. When you have done all these steps, the last step is to evaluate it. If you have done the right thing, you will get the desired result. That mental picture you have drawn in your head at the initial time, you will see that you will arrive at that answer. But when you didn't arrive at the answer, that means your steps you are not correct. You didn't follow it well, so you have to go back again. So those are the processes that are used in solving problem. Now, let's exercise our brain a little. From what we have discussed so far, discuss the various stages that will be needed to get a problem solved. The various stages that will be needed to get a problem solved. That should be a take-home assignment for you. What is the most important stage in the problem-solving process? What is the most important stage in a problem-solving process? So that should be, I didn't mean it's a live section, we would have discussed it, but let me leave it as a take-home for you. Let me leave it as a take-home. First of all, understand the problem, you formulate a model, develop algorithm, you write the program, you test the program, and finally you evaluate the solution, whether it meets the solution to your problem. We also did a little problem solving, basic problem solving, using all these steps I mentioned. So with this, we have come to the end of today's class. Oh, I would have asked you whether you have any question, but because it's not a live class, I will still encourage you that if you have any question concerning this, just send me a mail. You have my mails. Send me a mail. If you have anything confusing you, let us talk about it. So God bless you. Looking forward to have a live section with you next week Thursday. By God's grace, I believe that I'll be able to settle the technical inch. So please encourage other of your students to join the class. Thank you and have a blessed evening.